Here we go. We have a question kth smallest. So we have given an array and an integer k where k is smaller than size. Our task is to find kth smallest element in an array. It is given that all elements are distinct. So follow up is don't solve it using inbuilt function. So in this video I will talk about two approaches. So make sure to click on the subscribe button. We have an array and we want to find third smallest element. First smallest element is 3, then we have 4, then we have 7. So the answer is 7. The brute force or naive approach will be to first sort the array, then find the kth element. So it will work, but it is given that don't solve it using inbuilt sort function. You can build your own merge function also, but this is not recommended. I will tell you faster approach. First, let's suppose we have this array and we want to find our third smallest element. So first, second and third, this is our third smallest element. We only care about k elements. In this case k is 3. We only care about 3 elements. We don't need any other element. So let's suppose first we have 7, then we have 10. We have 10, 10 is bigger. Then we have 4. 4 is smaller. So till now our answer is 10. Till now our answer is 10. Then we have 3. As you can see, 3 is smaller. So we have to remove 10. 10 is of no use now. Our answer is now 7. So that's where priority queue comes in. In this is a max priority queue or max heap. Our topmost element represent the largest element. So in this case, if we have a window size 3, so our answer is 10 in this case. Third smallest element. First smallest element, third, and second, then third. Next, we have 3. So in this case, we will remove the topmost element. This is a max priority queue, so it will remove the topmost element. Then we insert our element. Then we have 20. In this case, we don't need 20 because 20 is much bigger than our topmost element. So we only insert, as you can see, third is smaller. So we only insert if in this case we have 10. So we only insert element. Next element is smaller. So let's suppose this is element I. So if I is smaller than our peak element, priority queue dot peak. So we remove the topmost element. So we remove priority queue dot remove the topmost element. So after removing, if our size is less than k, we want third smallest element. If priority queue size is less than k, so we will add. So we have a condition. If priority queue size is less than k, so we will add a element. So let's run it one more time so you get a clear understanding. First, we have 7. In this priority queue, our priority queue is empty. So we will not go here. Priority queue size is less than k. Size is 0. So 0 is less than 3. We add 7. Then we had 10. So 10 is greater. As 10 is greater, 10 is greater than this. 10 is greater than our peak element. So we will insert it only because size is less than k. Then we have 4. Size is still less than k. So we add. Then we have 3. We need to compare or we need to remove. We only remove element if topmost element is much greater than the current element. So if size, we reach the window, if priority queue size is equal to k. We reached the k elements. We reached the k elements. In this case, we have size as 3. 3 is equal to 3. So just to check, is the current element I is less than priority q peak element? In this case, yes. So we will remove the element. Then check priority queue size. In this case, 2. 2 is less than window size. It is 3. So 2 is less than 3. So we'll add our element. Then we have 20. 20. We have k elements. So just check, is the element, is the ith element is 20, is 20 less than our topmost element? No, it is not. So we will not remove the element. Next we have 15. Is 15 less than our topmost element, which means element is smaller? So in this case it is not. So we will not add or remove the element. So in this case we have only 3 elements. So we will remove, so we will return the peak element. So it represents the third or kth smallest element. Default priority queue is min heap. We need to convert into max heap. Topmost element represent maximum element. We need to convert into maximum heap. So let's code this. First we have priority queue. This is minimum priority queue. To convert into maximum heap, we just need to write this collections dot reverse order. So now it is maximum heap. After then we have to iterate. If priority queue size is greater, or we have reached the k elements, and current element is smaller, then we remove. And if size is less, we will add. At the end we will return peak element. Let's submit this. In between, let's talk about time and space complexity. So our space complexities, we only need k elements. So space complexity is order of k. And time complexity, first we have this. Removal takes log n time. In this case, priority queue elements are not n. We only maintaining k elements, so it is log k. And adding takes log k. So we have n log k. Time complexity is n log k. So let's jump into second approach. So let's take given array 7, 10, 4, 3, then 20 and 15. In this, we will maintain a frequency array. So our topmost element is 20. So this is 21 size array. So in first iteration, we will find our maximum element. First iteration, we will find our maximum element. Then we create a frequency array of maximum plus 1 size, because we need access to the maximum element also. First, then on second iteration, we will iterate and increment the frequency. For 7, we have frequency as 1. For 10, we have frequency as 1. For 4, 3, 3 frequency is 1, 4 frequency is 1. Then we have 15 and 20. 15 frequency is 1 and 20 frequency is 1. In this case, it is given that all elements are distinct. So our maximum frequency is 1. You can take integer array or a boolean array. Both will work in this problem. Then we need to find kth element, kth smallest element. So in this case, k is 3. So first, this frequency is 0, this frequency is 0, 0 and 1. 1 represent the element is present in an array only one time. So we will decrement this. It means we have found a smallest element. Next, we have this element. So again, decrement your frequency. Next, we have this element. So decrement your frequency. Now our k is 0. It means this is our kth element. Whenever your k is 0, so just return the index. Index represent the element number, the element present in an array. So that's how this algorithm will work. Let's code this. First, we have a maximum variable. Then on first iteration, we will find our maximum value. Then create a frequency array and increment the frequencies. In the third iteration, we are iterating till maximum frequency, and if frequency is greater than 0, we will decrement our k variable. Whenever k reaches 0, we will return ith value. And we also need to write something here, so I am writing return -1. So let's submit this. In between, let's talk about time and space complexity. In this, we are iterating 3 times order of n, then again order of n, then order of maximum. So worst case, our time complexity is order of maximum element, and our actually yes, order of maximum time complexity is n plus maximum element, and space complexity is maximum element because we have a frequency array. So that's it. So I hope you learned something new. If you have any doubts, feel free to ask in the comment section. The code is provided in the description box. Thank you all for watching.